All right, solving with radicals and rational exponents. So the big part of this lesson is going to be using those opposite operations to isolate the variable. So remember that the opposite operations are like the opposite of adding. The inverse operation would be subtracting. We got multiplying, that goes with dividing. And then the one that you're probably not as familiar with is exponents. And what's the inverse operation of exponents? That goes with roots. So if you have like x squared equals 16, you use the square root to solve for it. And anytime you take an even root, you do get two answers, like plus and minus 4. If you have the square root of x equals 6, then you use, so if the inverse of squaring something is taking the square root, if you have a square root, then the inverse is to square it. So you get x equals 36. So you go backwards. So that's kind of what we're going to focus on today. The cube root would be, the inverse of that would be to cube it. The inverse of a fourth root then would be to the fourth power, etc. So first, on the left here, you want to isolate your variable. So we got to get the x by itself. I'm going to start by subtracting 5 from both sides then. So I'm going to get negative fourth root of x equals negative 5. Then to get rid of this negative, I'm going to, it's like a negative 1 times the fourth root. So dividing by negative 1 on both sides makes this a fourth root of x to the fifth power. Then to undo the fourth root, you're going to use the fourth power, and then 5 to the fourth power. If you think about the fourth root of x as the same thing as x to the 1/4 power, and if you raise that to the fourth power, then power to a power, you multiply the exponents, and 1/4 times 4 over 1, that's just going to be x to the first power. So that's why the fourth root and the fourth power simplify just to x, and then 5 to the fourth power is going to be 5 cubed is 125, so 1 more 5 is 625. Okay, the one on the left here. First, I'm going to divide by 3 on both sides. That's going to give me my x by itself, so I'm going to get x to the 4/3. Whoops, that was hard to write there. X to the 4/3 equals now 24. Divided by 3 is 8, and then 1, so we got 81 here. So x to the 4/3 equals 81. Now I think it's easier to rewrite this in root form, and remember, if you have the nth root of a to the x power is the same thing as a to the x over n. So we can rewrite this as the cubed root of x, and then that's to the fourth power, equals 81. I like to rewrite it like that because now I'm going to undo the fourth power, so get rid of the exponent by taking the fourth root of both sides. So if I take the fourth root of both sides, the fourth root and the fourth power simplify, so I just have the cubed root of x left on the left. And then the fourth root of 81, since 81 is the same thing as 9 times 9, and that's 3 times 3. You can see that the fourth root of 81 is 3, but it's actually plus or minus 3, because think backwards, 3 to the fourth is going to be 81, and negative 3 to the fourth is also going to be 81. So you get plus or minus 3. When you take an even root, you always get two answers, just like when you square root something. Then we'll undo the cubed root by taking it to the third power, so to the third power on both sides. The cubed root of x to the third power is going to be x, and 3 cubed is 27, negative 3 cubed is negative 27. So you get plus or minus 27 as your answer. So just inverse operations. Okay, if you have a root here, you want to isolate the root before you, I'm going to have to square both sides to get rid of the root, but before I do that, I'm going to isolate. So I'm going to get the root by itself. So I'm going to start by adding 4 on both sides to get rid of that negative 4. So I'm going to get the square root of 2x plus 8 equals 10. Now to get rid of the square root, you need to square both sides. The square root and the square undo itself, so you're just going to be left with 2x plus 8 and 10 squared is 100. And from there, you just finish like solving a linear equation. You got subtract 8 on both sides, you get 2x equals 92, divide by 2, get x equals 46. Now when we have a square root, especially a square root or an even root, we want to go back and just check to make sure that we don't get any extraneous solutions. Anything that looks like an answer but isn't an answer. Remember, you can't have any negatives, no negative under the square roots, and you can't have any square roots equal to a negative number. So we just have to double check that the square root of 46 won't give us that. And if you plug in 46 here, you get 92 plus 8, square root of 100 will be 10 minus 4 equals 6. So you're good there. Okay, if you have two square roots in an equation, you need to get a square root equal to a square root. So you want a square root on each side, because then you can go through and square both sides to get rid of the square root. So if you have two square roots, you want one on each side of the equation. So I'm going to start here by adding 3 square roots of 2x to both sides, because then I have the square root of 4x plus 28 equals 3 square roots of 2x. Now to get rid of the square root, the inverse of that would be taking the second power, so I'm going to square that. Over on the left, you get 4x plus 28. And on the right, though, you're going to have to square the 3 and square the square root. So the 3 squared is 9, square root of 2x squared is 2x, and 9 times 2x is 18x. So that's how that works. It's the product of powers. You have a product here, so you have to take the power of both. Then I'm going to finish solving this by subtracting 4x from both sides. Get 28 equals 14x. Divide by 14. We get x equals 2. Go back up here and plug that in. Make sure I don't end up with anything negative. 4 times 2 is 8 plus 28. We're good there. 2 times 2 is 4. This is going to be square root of 36. 6 minus 3 times 2, which is 6, we get 0. So no negatives under the square root, no square roots equal to a negative number. We're good to go. Okay, so this one, I have just one square root and I have an expression over here. So to get rid of the square root, I do have to square this, which means I also have to square this. But if you have a something like 2 terms, call that a binomial, and it's squared, you have to use the FOIL. You have to FOIL this. This is the same thing as x plus 2 times x plus 2. And you can use FOIL, or the box method is another method that I've taught in my class previously. So if we FOIL this, you're going to get x squared plus 2x plus 2x plus 4. Combine your like terms, x squared plus 4x plus 4 equals, and then on this side, the square root and the square cancel, so you get 2x plus 28. So now you have an x squared, and if you have an x squared, that means that you have a quadratic equation. And the first step in solving a quadratic equation is that you have to have it set equal to 0. And then I've taught you multiple different ways of solving. You could solve by the quadratic formula. We have solved by factoring. Or another one that I taught you that's convenient is solve by completing the square. So those are your choices. So first, let's get it equal to 0. So I'm going to move the 2x to the left, and that's going to go with the 4x. And then I'm going to subtract 28, and that's going to go with the 4. So making sure to combine like terms there. 4x minus 2x is 2x. 4 minus 28 is negative 24. Now, if possible, factoring is going to be your best choice. Since this is just x squared, let's see. Can I factor it? So it'd be x times x gives me x squared. Needs to multiply to negative 24, add up to 2. And we do have negative 4 and 6 that multiply to negative 24, add up to 2. So we got x minus 4 and x plus 6. Now to solve by factoring, then you set each factor equal to 0, and we get x equals 4 and x equals negative 6. Then we go back up here and make sure that we don't get any square roots equal to a negative. So if I plug in 4, I'm going to get 4 plus 2 equals the square root of 2 times 4 plus 28. It's going to be 6 equals the square root of 36. It's good. 4 is definitely an answer. What about negative 6? We got negative 6 plus 2 equals, I'm going to get negative 4. 2 times negative 6 would be negative 12 plus 28 would be the square root of 16. Now, if you have x squared equals 16, then yes, x can equal plus or minus 4. But this is when you have an x squared. So you can have negative 4 when you take the square root because negative 4 squared is 16. So you're good. But if you have a square root by itself, it cannot equal a negative number. Think about when you graph the square root function. It starts at the 0 and goes to the positive. It's undefined for those negative values. So the square root by itself never equals a negative. So this is not true. The square root of 16 equals 4. So 6 doesn't work. We can't have a square root equal to a negative answer. This is called that extraneous solution. So x equals 4 is our only answer in that problem. So here's another example here. You can see what happens. So isolate the square root, so subtract 10. Square root, we get 6x minus 5 equals negative 7. Well, I just told you a square root cannot equal a negative number. So right here, I know that we have no solution. But we can continue solving it and see what happens. We'd square both sides, and we get 6x minus 5 equals 49. Add 5 to both sides. We get 6x equals 54. Divide by 6. We get x equals 9. Plugging 9 back in then. So 6 times 9 minus 5. And then square root of that plus 10 has to equal 3. So it's 54 here minus 5 is 49. So square root of 49 plus 10, does that equal 3? Does 7 plus 10 equal 3? No. So you can see that even if we do continue solving it, when we plug it back in, it doesn't work. So that's what we call an extraneous solution. It looks like an answer, but it is not. A square root cannot equal a negative number, nor can you have a square root of a negative number in the real number plane anyway. So we're looking at just real answers here. Okay, that wraps it up. Opposite operations, raise each side to a power, check for extraneous solutions.